Welcome to RIRCOM.
Radio receivers. In radio communications, a radio receiver is an electronic device that receives radio waves and converts the information carried by them to a usable audio form. Tuned radio frequency receiver. The definition of the tuned radio frequency, that is TRF receiver, is a receiver where the tuning, that is selectivity, is provided by the radio frequency stages. See the block diagram for the TRF receiver. In essence, the simplest tuned radio frequency receiver is a simple crystal set. Tuning is provided by a tuning coil and capacitor combination, and then the signal is presented to a simple crystal or diode detector where the amplitude modulated signal, in this case, is recovered. This is then passed straight to the headphones. Typically, a TRF receiver would consist of three main sections: tuned radio frequency stages. This consisted of one or more amplifying and tuning stages. Early sets often had several stages, each proving some gain and selectivity. Signal detector. The detector enabled the audio from the amplitude modulation signal to be extracted. It used a form of detection called envelope detection and used a diode to rectify the signal. Audio amplifier. Audio stages to provide audio amplification were normally but not always included. Superheterodyne receiver block diagram explanation. Signals enter the receiver from the antenna and are applied to the RF amplifier where they are tuned to remove the image signal and also reduce the general level of unwanted signals on other frequencies that are not required. See the block diagram for superheterodyne receiver. RF tuning and amplification. This RF stage within the overall block diagram for the receiver provides initial tuning to remove the image signal. It also provides some amplification. If noise performance for the receiver is important, then the stage will be designed for optimum noise performance. This RF amplifier circuit block will also increase the signal level so that the noise introduced by later stages is at a lower level in comparison to the wanted signal. Local oscillator. The local oscillator circuit block can take a variety of forms. Early receivers used free-running local oscillators. Today, most receivers use frequency synthesizers, normally based around phase-locked loops. These provide much greater levels of stability and enable frequencies to be programmed in a variety of ways. Mixer. Both the local oscillator and incoming signal enter this block. Within the superheterodyne receiver, the wanted signal is converted to the intermediate frequency. IF amplifier and filter. This superheterodyne receiver block provides the majority of gain and selectivity. High performance filters like crystal filters may be used, although LC or ceramic filters may be used within domestic radios. Demodulator. The superheterodyne receiver block diagram only shows one demodulator, but in reality radios may have one or more demodulators dependent upon the type of signals being received. Audio amplifier. Once demodulated, the recovered audio is applied to an audio amplifier block to be amplified to the required level for loudspeakers or headphones. Alternatively, the recovered modulation may be used for other applications whereupon it is processed in the required way by a specific circuit block. See the block diagram for SSB or continuous wave receiver. SSB, that is single sideband receiver, the section BFO. To receive the SSB transmitted signals in a radio receiver, a beat frequency oscillator that is BFO, is used to create an audio frequency signal. The remaining stages as used in Superheterodyne Receiver. When receiving SSB, it is necessary to have a basic understanding of how a receiver works. Most radio receivers that will be used to receive SSB modulation will be of the Superheterodyne type. Here the incoming signals are converted down to a fixed intermediate frequency. It is at this stage where the BFO signal is mixed with the incoming SSB signals. It is necessary to set the BFO to the correct frequency to receive the form of SSB, either LSB or USB that is expected. LSB is lower sideband, USB is upper sideband. Many radio receivers will have a switch to select this. Other receivers will have a BFO pitch control which effectively controls the frequency. The BFO needs to be positioned to be in the correct position for when the signal is in the center of the receiver passband. This typically means that it will be on the side of the passband of the receiver. The position of the BFO tune the SSB signal in for the optimum strength, that is ensure it is in the center of the passband, and then adjust the BFO frequency for the correct pitch of the signal. Once this can be done, then the main tuning control of the receiver can be used, and once a signal is audible with the correct pitch, then it is also in the center of the receiver passband. CW wave, that is continuous wave or carrier wave. It is an electromagnetic wave of constant amplitude and frequency, almost always a sine wave. In radio transmission, in which a sinusoidal carrier wave is switched on and off, information is carried in the varying duration of the on and off periods of the signal, for example by Morse code using did and da.
Thank you. Watch, subscribe and like.